Well, we're back here at the Cave of Science, and we're looking at, excuse me, Unit 5, Worksheet 2. So the first one says, you got a penny that's pretty much pure copper. Penny has a mass of 3.3 grams. How many moles of copper atoms would be in one penny? This one's kind of stated a little funny. Really, they're looking for how many moles, so we don't need to worry about how many atoms there are. So, again, 3.3 grams of copper. And as we mentioned in class, first thing you always do is convert grams to moles. And if we look on the periodic table, 1 mole of copper is 63.6 grams of copper. And doing the math, we'll come out with 0.052 moles of copper. And again, you look at the atomic mass for copper on the periodic table, and you come out with 63.6. Number 2, we got 4 nails, have a total mass of 4.42 grams. How many moles of iron atoms? And again, we're really looking for moles of iron. Do they contain? Well, we got 4.42 grams of iron, which is Fe, and we know there is 1 mole of iron has a mass of 55.9 grams, and that equals approximately 0.08 moles of iron. And again, grams of iron are gone, you're left with moles of iron, and that's what your answer needs to be. Got a raindrop, so again, water is H2O. How many moles of water does a raindrop contain? And our raindrop has a mass of 0.050 grams. So mass converted to moles. 0.050 grams of H2O. And again, I like to put that over 1. And we know 1 mole of H2O. Well, we got to figure out what that is. So for hydrogen, we have 2 and it has atomic mass of 1. Oxygen, we have 1 and it has atomic mass of 16. So this equals 2, this equals 16. So water has an atomic mass of 18 grams. So 1 mole of water over 18 grams of water. And again, grams of water cancel out. And if we do the math, comes out to 0.003 moles of H2O. So not too bad on that one. Question number 4. What mass of water would you need to have 15 moles of H2O? Well, this is what we've got. We got 15.0 moles of H2O. And we want to really convert this to grams. We know that there in 1 mole of H2O, there's 18 grams of H2O. And again, the 18 grams you can get from the previous problem right here. And if we do the math, what's the mass of water? Comes out to be 270 grams of H2O. So not too shabby on that one. Let's look at question 5. 1 box of Morton salt contains 737 grams. How many molecules of sodium chloride, NaCl, is this? Again, sodium chloride, you need to find out the molecular, or actually the formula mass in this particular case. So we got 1 chlorine and 1 sodium. Sodium has a mass of 23, so that's 23. Chlorine is 35.5. And again, you go to your periodic table to get this. So that's 35.5, or 35.8 Yeah, 35.5. So if we add those together, so 0.5, 8, 58.5. Well, it's really the same problem here. 737 grams of sodium chloride all over 1 times we have 58.5 grams of sodium chloride is 1 mole of NaCl. And if we do the math, we have 737. So 737 divided by 58.5 equals about 12.6 moles of sodium chloride. Again, a pretty straightforward problem there. Question number 6, we got chocolate chip cookies, calls for 0.050 moles of baking soda, sodium bicarbonate, NaCO3. How many grams should the chef mass out? Well, we got to find the mass of this particular compound. So we have 1 sodium, that's 1. We have 1 hydrogen, we have 1 carbon, and we have 3 oxygen. Sodium has a mass of 23, so that's going to equal 23. Hydrogen's got a mass of 1, so that's going to equal 1. Carbon's got, 1 carbon, it's got a mass of 12, so that's 12. And oxygen is 16. 3 times 16 equals 48. And if I got this together correctly, I think that comes out to 84 grams. So we've got 0.050 moles of NaHCO3. Again, I like to put that over 1. And we know 1 mole of NaHCO3 has a mass of 84 grams of NaHCO3. Moles cancel out, and if my math is correct, that is 4.2 grams of sodium bicarbonate, NaHCO3. Again, very, very similar problem. Problem number 7. Rust is iron 3 oxide, Fe2O3, and it goes through talking about a Cadillac, and essentially how many moles of iron 3 oxide are contained in 2.5 kilograms of rust. Well, again, we've got to find the formula mass of iron oxide. So Fe, so for iron, we have, it's Fe2, so we have 2 of those. Oxygen, we got 3. We know oxygen's 16, so that should be 48. Oops, let me push that over a little bit. 48. Iron has a mass of 55.9, and if you multiply that out, that comes out to be 111.8. My math is right. Add them together, 159.8. We got 2.5 kilograms of rust, so we probably should convert that to grams. So we can do that pretty easily. 2.5 kilograms all over 1. We know 1 kilogram has 1,000 grams, so that's going to equal 2,500 grams. Well, we got that much rust. Now we got to find out how many moles that is. So we have 2,500 grams of Fe2O3. And again, I like to put that over 1. We know 1 mole of Fe2O3 is 159.8 grams of Fe2O3. And we go ahead and do the math, and we come out with 15.6 moles of Fe2O3. Alright, so there's the front side of that. Alright, let's flip it over and see what we have here. Some of these I might end up putting on a different piece of paper just because they get just a little bit longer. Oh, you can read through the problem, but really what we want to know is how many moles are there in 0.75 grams of ammonia and how many molecules. So actually I'm going to put this on a different sheet of paper here. Give myself a little bit of room to work here. And again, we got to take ammonia, NH3, so there's 1 nitrogen. The atomic mass is 14, so that's 14. Hydrogen, we have 3 times 1, so that equals 3. So ammonia has a mass of 17. Well, we're given 75 grams in how many moles? So 75 grams of NH3, now again I like to put that over 1, times 1 mole of NH3 is 17 grams of NH3. Grams are gone again, so we're left with 4.4 moles of NH3. The next question with this particular problem, it says how many molecules? Well, now we're going to start using Avogadro's number. We've got 4.4 moles of NH3, and we know 1 mole of NH3 is 6.02 times 10 to the 23rd molecules. Molecules of NH3. So if we go ahead and do the math, we come out with 2.7 times 10 to the 24th molecules of NH3. All right, so let's look at, so that was number 8. And let's look at, I think I'm going to put the next 3 on another video. So why don't we cut this one off right here.